So in this example, we have an application. Let's see what it says. The cost C in dollars for a company to produce and sell X thousand gadgets is given by the function C equals 140 x squared 1 over 40 x squared minus 2x plus 4,540. And then we have three different questions we want to ask. We want to solve. What is the company's startup cost? What is the minimum cost? And how many gadgets must I think there's something missing there. Let's see. How many gadgets must the company, I think it's supposed to be the company, produce and sell in order to incur the least cost? Typo. Anyways, the startup cost based on the given function will be our y-intercept, all right? Because the function is based on the number of items sold, so the number of gadgets produced, and that will give you the amount of money. So for part A, we want to find the y-intercept. All right? Startup cost, before they can produce anything, any gadget, how much will they have to have in, the cost? So we're going to substitute 0 for x and see what we get for y. All right, this right over here, 0 squared, 0, times 1 over 40, 0. That's gone. Negative 2 times 0, 0, gone. Startup cost is 4,540. Yay, that was not that bad. The second question, part B, it wants us to find the minimum cost. Keyword, we need to find the vertex. Vertex, keyword. And the keyword for the first one is startup. The y-intercept is your starting point. So in order to find the vertex, we're going to use this formula over here. This is to find the x part of the vertex. Let's go back. It's not writing it how I didn't write it how I want it. So x equals negative b over 2a, which that will be, remember, the standard form of a quadratic is this. Which means a is 1 over 40, b is negative 2, and c is the 540. So we're just going to substitute here. Negative times a negative divided by 1 over 40. Let's do one step at a time. This is positive 2 divided by 2 times 1, 2 over 40. And it looks like a complicated fraction over there, but if you simplify that and take your time, 2 divided by 2 over 40. We use something that we learned somewhere, I believe in 3rd grade. Keep, switch, flip. Keep the first fraction, switch your sign to multiplication, and flip the second one. Now this is just a multiplication. If you remember, you can simplify this. This is a weird looking 2. It looks like a Z, but you said 2. These 2's will cancel, and that will leave you with 40. Or you can say 2 times 40 is 80 divided by 2, still 40. All right? So that's the x part of the vertex. We need to find the y now. So we need to evaluate the function when x is 40. All right? C of 40 equals 1 over 40, 40 squared, minus 2 times 40, plus 45, 4,440, 4,540. All right. And we're going to do one thing at a time. If you have a graphing calculator, you can type the whole thing, but if you don't, you do one step at a time. So 40 squared gives you 1,600. And you're going to multiply that times 1 over 40, which gives you 40. Then minus this gives you 80, plus this guy. That gives you negative 40, plus this guy. If I'm not mistaken, that gives you 4,500. Doesn't write good sometimes. I don't know if it's the pen or if it's me. Let's blame it on the pen. So that gives me the vertex. The minimum cost is 4,500. Because sometimes you feel like it's writing and then it's not really writing. All right. And then part C. Let's go back and read it because we already saw for it. How many gadgets let's see, how many gadgets must the company produce and sell in order to incur the least cost? So for part B, we found the minimum cost, right? So how many gadgets did they produce in order for that minimum cost to happen? That is the X part of the vertex. This is the 40. Is the minimum number of gadgets. Now let's see something because there's something that we have to change. If you notice here, it says the number of gadgets held in X thousands. So we need to multiply this 40 times 1,000. So the minimum number of gadgets to produce is 40,000. Did I spell that right? Let's see. Yeah, gadgets. All right. Perfect. And here we have our 3 answers for this application. Excellent, excellent.